So my last page is solving systems by substitution, and I need lots of room for those, so I'm going to recopy the problems onto my notebook paper, and then I'm going to move my review sheet so I have room to work the problems. So in number 38, solving by substitution, you've got to get one of your variables all by itself, and we always choose the variable that has 1 as a coefficient. So if I want x by itself, I'm going to add 8y to both sides. So now x is by itself. X is equal to -8 plus 8y. Why did I do that? Well, because I want to take this whole expression, -8 plus 8y, and I'm going to substitute it into my other equation everywhere that I see an x. So I'm going in -3, and instead of an x, I'm putting -8 plus 8y. And then I continue on writing the rest of the equation. Why did I do that? Because now I have one equation with only one variable in it, which I can solve. So I'm going to use my multi-step equation skills, and let's see, -3 times +8, that's actually -24y, and plus 2y equals -20. So now I'm ready to combine like terms. -24 plus 2, that is -22. And let me subtract 24 from both sides. Getting closer. -22y equals -44. So I divide both sides by -22, and I get y equals 2. So now that I've got one of my variables solved for, I want to take that and plug it back in to my original substitution equation. I know that x is equal to -8 plus 8y, and since now I know y is 2, now I have an equation that just has one variable in it. So -8 plus 16, so I get x equals +8. So I'm done solving a system of equations once I have values for x and y, and I can write my solution as ordered here. So these problems are quite complex and they have many steps. Definitely practice all 4 problems. It'd be best if you could pause the video and try to work them out on your own first. For number 39, x plus 2y equals 6, and -5x minus 7y equals -21. So again, when we're doing substitution, we want to get one variable by itself. And this one's going to be similar to the last one, where the variable to get by itself is the x in the first equation. So I'm going to subtract 2y from both sides. So I get x equals 6 minus 2y. And I'm going to take that expression and substitute it, since that's what x is equal to. I'm going to plug it in over here where x is. So -5 times 6 minus 2y, then keep writing the equation, minus 7y equals -21. And now we've got a rather complex equation, but we know how to solve, assuming we don't make any careless mistakes. -30 minus 5 times minus 2 is plus 10y. Then keep writing the equation. Now I'll combine my terms. -30 plus 3y equals -21. Add 30 to both sides. Get 3y equals +9. So y equals 3. So once I have one variable solved for, I will plug it back in. So x equals 6 minus 2 times whatever y is. In this case it's 3. 6 minus 2 times 3 is 6. 6 minus 6 is 0. So writing my solution as an ordered pair, there you go. Let's go ahead and do number 40 on this same paper. These problems take up a lot of room, but we can't let that bother us. 2x plus y equals 7. 2x plus 7y equals 1. So this time I see that the best variable to solve for would be this y right here. It has a coefficient of 1, so I'm going to subtract 2x from both sides, and I get y equals 7 minus 2x. I'm going to plug that in here for y this time. So 2x plus 7 times 7 minus 2x equals 1. Distribute. 7 times 7, 49. 7 times -2 minus 14. I'm going to combine like terms. 2 minus 14 is -12. Subtract 49 for both sides. We get -12x equals -48. And I was hoping that would happen because I know that 12 goes evenly into 48. So x equals 4. And now I'm going to plug that into my original. So I know that y equals 7 minus 2 times 4. Y equals -1. 2 times 4 is 8. So 7 minus 8 is -1. So I've got my two answers. So I'm going to write my solution to my system as an ordered pair. I'm going to leave you to work number 41 on your own and check your answer. It is 8, -7. And number 42, let's read the problem and set it up, and then you can solve for it. Dance school is selling tickets to the annual dance competition. On the first day of ticket sales, the school sold 1 senior ticket and 2 child tickets for a total of $11. The school took in $7 on the second day by selling 1 senior ticket and 1 child ticket. What's the price of each senior ticket and 1 child ticket? So I'm going to say S is the price of the senior ticket, and C is the price of a child ticket. And I'm going to write a system of equations based on those two variables in my two sentences. So we have 1 senior ticket and 2 child tickets. So 1 senior and 2 child tickets together are $11. Then we have 1 senior and 1 child is $7. So that's going to be your system of equations. You may choose to solve that using substitution or graphing. And you're going to get final answer. Senior ticket is $3, child ticket is $4. And number 43, flying with the wind, a plane went 118 miles per hour. So flying into the wind, he went 80 miles per hour. So this is a little unusual for a problem. We have the regular speed of the plane, and then we have the speed of the wind. So, and when they tell you something is flying with the wind, that means the wind is helping. helping gives you 118 miles per hour. The wind going against you gives you only 80 miles per hour. So those are going to be the two equations, and you solve those. And you get plane speed is 99 miles per hour and the wind speed is 19. The last set of problems has to do with sketching inequalities. So it's a little challenging to demonstrate with the solutions already here, but I'll do my best. So the steps are to graph each equation as if it were an equal sign, and then you have to look at the inequality symbol. So this one's a greater than, so I know it's going to be a dashed line, and this one is less than or equal to, so it's going to be a solid line. So if I'm graphing the equation y equals negative 3x minus 3, I'm going to go to negative 3, and then I'm going to do a slope of negative 3. So I rise 3, and then I run 1 to the left. And then when I plot that, I have to use a dashed line. So then I need to decide on the shading. So I'm going to go back to my inequality symbol, and I'm going to plug in a test point of 0, 0. So if 0 is x and 0 is y, I'm plugging in 0 for both, and I get 0 is greater than negative 3 times 0 is 0, minus 3. Is 0 greater than negative 3? Yes. So that side of that line gets to be shaded. The side that contains 0, 0. Then I want to plot the line y equals negative 1/2 x plus 2. So I go to 2, and then I want to rise 1 and run 2 to the left. And I'm going to plot that line with a solid. And again, it's less than or equal to. So I'm automatically looking below the line. My favorite test point is in that region. So I'm going to plug in 0 for y, and then I'm going to plug in 0 for x. And when we work out the math, negative 1/2 of 0 is 0, plus 2 is 0, less than or equal to 2. Yes. So therefore, I'm going to plot the region below that line. And I can quickly see that my overlapping region is this area that's shaded pink right here. And in number 45, you can take a look at the solution. You've got so 4x minus 1, that's going to be this line right here, and it's solid. And negative x plus 2, that's this line right here, and it's dashed. And then it looks like everywhere we plugged in a test point of 0, 0, it didn't work out, it was false. So we never ended up shading over here where 0, 0 is located. So remember, when you plug in 0, 0 and it's false, you shade the other side of the line. So that's what happened here. You can see the solution and check your answers. And that concludes the videos for the review for semester exam.